All right, everybody. So for today, we're going to be talking about final review units 3 and 4. So remember, also have your word wall ready with unit 3 and number 4. Have it handy. So the first two questions when we look at these problems are asking about factoring. So when they're asking me to factor, then we know that the first thing we want to do is we want to start looking for what we call the GCF. So according to our word wall, that is the very first step we take. Now, when I'm looking at it, this one has a letter B, this one has a letter D, so we can't take out a letter for a GCF, but then I can think about these numbers 27 and 125, and we could try to find a number that goes into both. But I'll tell you right now that there is no number that divides the 27 and the 125, I believe. Yeah, there is no number that divides them both. And so because of that, we're going to go into our next step. So GCF is always first. Now, when I look at this, it does have one term. It has two terms. So when I'm looking for two terms, it can either be a difference of two squares, but this has to carry a power of 2. And clearly we see powers of 3 here, which then means it could also be this one. It could be a sum of 2 cubes or a difference of 2 cubes. But in order for one of these to work, now I'd see the one with the plus sign, I need to know what my A and B are. So when we're looking at this, and we have a list here that's going to come in handy from our word wall, we want to break this thing down so that it has powers of 3, but on the outside of a parentheses. Because what I'm going to need here is, this is going to be my A value in yellow. This is going to be my B value that we're looking for. Now, if you're wondering, well, what multiplies 3 times to give me a 27? Well, this is why we have our list here. See, there's the number 27. And so 3. 3 to the power of 3 will give me a 27. So for the 27, we're going to put a 3 in here. And then look at what else has a power of 3. The letter B does. But I'm not going to write it with a power of 3. I just write the letter B once. So 3 to the power of 3 is 27. B to the power of 3 takes care of the B to the third. So I'm going to do something very similar to this one. So again, here's another way of thinking about it. I'm taking the cube root of 27. That's why I wrote a 3 here. So when I look at the 125, I'm going to take a cube root. Remember, these are cubics that we're working with, of 125. And when I look at my list here, there's the 125. It's kind of small, but we can see it there. I get an answer of 5. So I'll put a 5 in here. Don't forget, it does have a letter D to the third. Well, then I'm going to write the letter D here. So keep in mind, this right here is my A, not with the power of 3. This right here is my B. And again, we're talking about the A and the B that we see in our formula. So according to this formula, I'm just going to copy what the word wall says here. Again, great use of the word wall to help us out. A plus B times A squared minus AB plus, just copying the word wall here, plus B squared. Remember, all of these values are going to get filled in, and we already know what we're filling them in with. That's why we broke down the problem earlier. Here's the B values in orange, and that's where I'm going to write my 5D. So now let's plug it in. It says A, so that's 3B, plus orange is 5D. Okay, my first one has a power of 2. It says put the A value, so that's 3B, minus, I have 2 values here that we're going to write in. We have my A value, which is 3B. We have the orange value, which is 5D, plus we have this last one to the power of 2, and that's where I write the 5D. Now, okay, so the next thing we're going to do is take care of everything that has a power. Now, this first parentheses is done. So we have our first parentheses, and again, that's part of my solution. What we have here, though, is, don't forget, we have a power of 2, but everybody's going to get their own little power. The 3 gets a power of 2. Well, 3 times 3 is 9. The b gets a power of 2, so it's b squared. Minus. Now here, all I have to do is simple multiplication. 3 times 5 is 15. And then, of course, the b times the d is bd. Plus, we're going to square the 5. So 5 times 5 is 25. And then the letter d also gets its own power of 2. And then the nice thing about it is when we're using one of these formulas, we do not have to change any of this. This is it. This is our final answer for this problem. And now we can move on to the next one. But again, we do need to know what my a and b are for this. And so we plug it in where it belongs. Now, the other one also says factor, but I noticed right away that it has 1, 2, 3, 4 factors, or sorry, 4 terms. So when we're looking at 4 terms, this is where grouping is going to kick in. When we're looking at factoring by grouping, we're basically going to cut it all down the middle. So I'm going to cut it down the middle here. And I'm going to, so it says draw a line down the middle. Okay, we did that. Take the GCF out of each group. So when I look at this one, the first one has a GCF. Well, let's see, they both say X, so I'm going to write X. But I can take out 2 of them. We take the smaller amount out. On this one, I'm going to think about the GCF here as well. And there is no letter, but the number that divides a 4 and a 12 is the number 4. And if they're both negative, well, then I'm also going to take out the negative. So here we go. We are going to write out our GCF first. And in parentheses, look, it has a plus sign. So we make sure we put that in there. The GCF here is negative 4. Now this one I'm going to hold off on the sign for now. All right, well, here we go. I am taking out an x squared from each one of these, meaning it's completely gone on this one, leaving me with a 3. But here I have 3 x's, but I need to take 2 of them out. Well, then I'm left with 1. I'm going to do the same thing on this side, but I'm going to divide everybody by negative 4 here. So negative divided by negative is positive 1. Negative 12 divided by negative 4 is positive 3. Again, that's why I held off on the minus sign here for this one, because it might change. All right, so there. I took out the GCF of each group, and now I'm going to factor out the common factor for both of these. Well, the only thing that both of these have in common is this parentheses. So I'm going to write that parentheses here, x plus 3. Barely see it there. So there's the x plus 3. And in my other parentheses, well, I'm going to write down whatever's left. The only thing left that I didn't underline was the x squared and the minus 4. Now, when we still have a power 2, we might need to take it further. So we have the x plus 3. But now when I have a power of 2, it does look like this one here. It's called the difference of squares. Let me line it up a little bit better there. Where if you have things that have a power of 2, one has a plus, one has a minus. This one has a minus. This is a power of 2. Don't forget that if I do a square root of 4, it is a 2. So this is just 2 squared. This is x squared. So it does look like my word wall now, which means I get to put 2 parentheses, one with a plus, one with a minus. Go. And then, of course, x is first, so we write x into each one. The 2 is second, so we write 2 into each one here. And just like that, we have officially factored this 4-term binomial. We have fully factored this one. All right, well, that brings us to question number 3, where they want me to divide polynomials. So when we're doing division, unfortunately for this one, looking at our word wall here, yeah, we're doing division. That means we're going to do this long division stuff. You just have to remember, if there's a missing value, you do need to put in a 0 for it. Just remember, this is going outside of the division box. This is our divisor. So we're going to go 2x plus 1 on the outside. And on the inside, we're going to write 6x to the third minus 3x squared plus x minus 3. And notice nothing was missing. Power of 3, 2, 1, 0. So no zeros needed. All right, here we go. We got to start the process. The process says that I'm going to start with this one and this one. And all I have to do is on the side go 6x to the 3 divided by 2x. That leaves me with a 3x squared. So I'm going to write it right here because I want my x squares to line up. Now that I know what I have on top, I'm going to multiply it once. 3 times 2 is 6. X squared and x1 is x to the third. And this is how I know we're doing it correctly, because we have a perfect match. But we still need to multiply one more time. 3x squared times 1 is positive 3x squared. Okay, so according to the word wall, the next step is to subtract. But remember, I am subtracting both of these. So one of the things you can do is you can go in and change all of your signs. When you distribute that negative, well, this becomes negative. You distribute the negative over here, this becomes negative. And now it just becomes combining like terms. This is gone. Negative 3 minus 3 is negative 6x squared. And then we bring down the next term. And now the process starts all over. Except now, this is what I'm going to work with, and this one. So I'm going to go off to the side here again. We're going to go right off to the side, and I'm going to take the negative 6x squared, and again, I'm going to divide it by 2x. All right, well, think about what we mentioned in the past. Negative 6 divided by 2 is negative 3. x2 and x1, you subtract your powers. There's my x. So I'm going to bring that up here. Negative 3x. Now we're going to do our multiplication. Negative 3 times 2 is negative 6x squared. Negative 3 times 1 is negative 3x. We said we are going to subtract, but when we subtract, we are basically changing all of these signs. So this is going to become a positive. This is going to become a positive. And now we're ready to combine. See, they're ready to cancel out. Invisible 1 plus 3 is a 4x. And we bring down our very last number, negative 3. But the process starts all over again. But now I'm working with this number. We always start with the leads. This is a 4x, this is a 2x. So I'm going to go 4x divided by 2x. Well, 4 divided by 2 is 2. 1 minus 1, that means all your x's are gone. This is the only number I'm going to bring up here. All right, last time we do this, 2 times 2, 4x. See, everything lines up. 2 times 1 is just a 2. But we are going to change all of the signs because we are subtracting. So this becomes a negative. This becomes a negative. Now I can combine because I changed them. The 4x is gone. And negative 3 and negative 2 make negative 5. And that's what we call our remainder. So the only question left is, okay, then how do I officially write my answer for this problem? Well, I have to copy everything up here. There's the 3x squared. There's the minus 3x. There's the plus 2. But when we have a remainder, we always say plus, but we write it as a fraction. And my remainder of negative 5 goes on top. And then what do I put at the bottom? Well, don't forget, this is what we were dividing by early on in the problem. We were dividing by 2x plus 1. Well, that's what we're going to put here, 2x plus 1. All of this becomes our result. So there will be some questions in the final that are a little bit longer than others. Well, definitely one of the longer problems. All right, give you a moment to catch up with the writing. And then once you're ready, we're going to flip the page. Okay, so I have a few more here. 1, 2, 3, 4, about 5 more questions to go. Okay. And now we're going to be solving the equation, but notice it does have fractions. Anytime as a fraction, we do need to check our answers, but that's why we have calculators to do that for us. But we will be checking our solutions to these problems here. Okay. According to the word wall, one of the things that we said was when you are solving and you're working with fractions, so this is unit 4. Okay, here we go. Now, this is if it says fraction equals a fraction. I don't have that here. When you have more than one fraction on a side, determine the LCD. Then you multiply everything by the least common denominator. All right, well, LCD is one of the easier things because if I'm looking at my denominator, this is one denominator, even though there's two things. Put a parentheses around it. And then here's another one. These two are completely different. So my least common denominator, I'm just going to write them down. There's a p minus 3. That's one of them. And then the p by itself is different. Well, then all of this becomes my LCD. So I need some space, so I'm just going to write them down again. But I'm going to put it in parentheses. Plus, again, I'm just going to leave some space here. There's the letter P underneath. Equals, and then again, I'm going to write the 1 here. What it says is, once you find your LCD, you're going to multiply everything by the LCD. So I will put a big parentheses around this and write P minus 3. Put a parentheses around this and write P times P minus 3. And then over here, same thing. Maybe I'll put a dot here. And then P times P minus 3. We do it to everything it says. And the whole point of this is we should not see any fractions after this. See on this one, the P minus 3 cancels with the P minus 3. Over here, the P cancels with the P right here. And that's it. There is no more canceling. So all I have to do now is do a little multiplication. P times P squared. This one requires a little bit of work. 6 times P is 6P. 6 times 3 is 18. And it equals, well, there's no canceling on this one, so you do have to distribute again. So it says P squared minus 3P. So that's with the distribution. Now, we do have a power of 2, which usually means I need to set this thing equal to 0. So one of the first things I'll do is subtract the P squared. And then, of course, I will add the 3P because I do need to equal 0 here. That's what we normally do when we have a quadratic. But then the nice thing about it is the quadratic actually disappears on us. And it leaves me with 9P minus 18 is equal to 0. So now it's just an equation of a line. So then keep in mind your ultimate goal is get P by itself. Then add 18 to both sides. Low on space here, but 2P is equal to 18. Sorry, 9P is equal to 18. And then when you divide by 9, barely fit there, we get that P is equal to 2. But they did say check for extraneous solutions. Remember, the only thing in math you can't divide by is 0. So when I plug in a 2, 2 minus 3 is not a 0. Plug in a 2 into this one, well, that's not a 0. Then we should be okay. This is our result. Now, number 8 is basically the exact same problem. So we're just going to kind of speed through it a little bit just to practice that idea of the LCD. So when you do the LCD, remember, this is considered one denominator, and that's different. So I'm going to write it down. This letter D by itself is different from this one. That's a different denominator. Well, then I write it down. And now that we've done that, well, now I'm going to multiply everybody. So here's the D minus 6, plus 12 over D equals 1. I'm going to multiply everybody by d, d minus 6, d, d minus 6, and d, d minus 6. We do it to everybody, even non-fractions. So on this one, the d minus 6 disappears. See, same thing we did up here. D times d is d squared plus, all right, look at this one. This one, the letter d disappears. So a little distribution. 12 times d is 12d. All right, we might need a calculator here, but negative 6 times 12 is negative 72 is equal to, again, nothing cancels on this side, so d times d is d squared, and d times negative 6 is negative 6d. But again, the issue here is the fact that we have a power of 2, which makes it a quadratic, so I need to set it equal to 0. But when I take this first step, we realize the power of 2 is actually going away from both sides when I do the subtraction. So then it is no longer a quadratic. Then I don't need to make it equal to 0. All I have to do is just solve for the letter d. So how do I get rid? Well, I don't want to move this one over here. Let me just get rid of the 12. So we get rid of the 12 here. Negative 72. All right, combine these two, get negative 18d. And when I divide by that negative 18, then just like that, we should be done. D is equal to, and again, you might need a calculator for this one to double check your result. But when you work this one out, negative 72 divided by negative 18. All right, we got a nice little answer of 4. And again, normally you should be checking your answers to make sure it works properly. But it should be okay. 4 minus 6 does not result in a 0. Plug in a 4 here, it does not result in a 0 either. All right, so we gave you two of the same type because they tend to be the problems that people miss the most on the final. So we just want you to practice as much as you can here. All right, now this one does not have an equal sign. So all they want me to do is simplify. Do whatever math you can. Now it's a fraction with a plus sign, so let's see what it says about adding fractions. Identify the lowest common denominator. You may have to factor, but your first goal is to match the denominators. But you should factor first. So let's do factoring. All right, so again, I'm not changing anything. The top is just staying the same. We are not making any changes yet. They said the first goal is to match the denominator. X plus 6, yeah, we can't do anything with that, so I'm just going to leave it alone. Call it x plus 6. But look at that, x squared minus 36. That has a power 2. That means, yes, we're going to factor it out. And when I'm looking at my word wall, when it comes to factoring, we just saw one earlier. Try to make it fit there. So it looks like this one, where this is a power of 2, so that would be the x. Question is, what has a power 2 that I could put in here for the 36? The word wall tells me it's going to be a 6. So this is x plus 6, and this is x minus 6. But one of the things that the word wall says when we're doing this is your job is to match the denominator. So if I'm going to match the denominator, it's time for me to do that, and let's see. Do they both say x plus 6? Absolutely. Do they both say x minus 6? The answer is no. So if that's the case, this one right here is missing the x minus 6. So here's how I'll take care of it. Let me give myself a little more room here. So it already has the x plus 6. Well, that's good. Notice we haven't done anything else yet. So they both say x plus 6. All right, well, that's great. We don't need that. The problem is this one says x minus 6. Well, that's what this one needs. But if the rule is if you give it to the bottom, you have to give it to the top. This one here doesn't need anything. This one's ready. This is the one missing the x minus 6. So we're going to give it up here, x minus 6. This is the only one that needed something. All right, well, I'm ready. The bottom part is done. I no longer have to worry about the bottom because now they officially match. So I don't need two fractions. I'm just going to have one now. 3 times x is 3x. 3 times negative 6 is negative 18. And yeah, this one didn't have any work, so I'm just going to write plus 4x, which means here's my final answer. X minus 6, x plus 6 is done. Again, as soon as your denominators match, that's all that matters. The Wordwell said multiply to create a common denominator. Okay, I did that. All I have to do now is just combine like terms. And the only ones that I can combine are the 3x with the 4x. So when I combine these two, 3 plus 4, there's my 7x, and the minus 18, we couldn't do anything with, and there's my final answer. All right. 2 more to go. Multiply the expression, simplify the result. Let me look at my word wall. When it says multiplying expressions that are fractions, it says factor and cancel. First step, make one big fraction. Factor if needed. So they said make one big fraction first. And now it says x squared minus 9. So I'm going to have to factor that. Now we just saw that earlier. These are the two that end up as 2 parentheses. One with a plus, one with a minus. With all the factoring you've done throughout the year, it says x squared, so we go x and x. But of course I need to break down the 9, so if I'm going to look at the number 9, that's where the number 3 is going to kick in. So for the number 9, we go 3 and 3. This one is officially done. But now, still on the top, it says x squared. Well, there's not much I can do with x squared. I mean, you could write it like this. We could write it as x times x. That might come in handy. So you know what? We're just going to write it out. It might come in handy there. Now, top is done. So now I need to worry about the bottom. When I look at the bottom, the very first step in factoring is GCF. Well, this one does have a GCF. See, they both have an x involved, which means the GCF is x. So for this orange one here, if I'm bringing up the concept of GCF, well, they both say x, so then I need to write the x first. But now I'm going to divide everybody by x, meaning 2 minus 1 is 1, so I still have an x. There's a minus sign. The 3 is there. I'm not messing with the number, but the x's would disappear for that one. That's what GCF is, where we take out whatever they have in common. And if you look at it, we can't do anything else. Which leaves us with this last one here. X squared plus x minus 6. Well, this is a trinomial, so I know I'm definitely going to be able to factor that here. So remember, this is all where we practice our factoring. I'm going to have 2 parentheses. There's an x. Well, then that means x and x. And all I have to do now is break down the 6. 6 times 1, 3 times 2. Those are my options for getting a 6. And then the goal. The goal is to subtract to get a 1. Well, the only numbers I can subtract to get a 1 are 3 and 2. And if I'm trying to get a positive 1, there's my 3, there's my 2. But if all I'm trying to do is get a positive 1, then the 3 should be positive, and the 2 is my negative. All right, after all of that, this is what the problem should look like once it's been factored. Well, it said factor and cancel. So I can cancel anything out from the top with anything else from the bottom, but they have to be a perfect match. So when I look carefully, look, x plus 3, gone. There's an x minus 3 and an x minus 3, all or nothing, gone. Remember how we wrote the x squared twice? It does come in handy. Look at that. This single x cancels with this single x. And if you're thinking, oh, cancel these x's, remember this has a -2, all or nothing, which means I can't cancel anything else. So I'm left with an x on the top and an x -2 at the bottom. Again, you cannot cancel these. It's all or nothing, which means there's my answer for this problem. All right, give you a moment there to catch up with the writing. So for the last problem in this review, remember the rest are honors here. It says divide the expressions. Now, when we're dividing fractions, right, we have to take this back to our elementary days when our teachers said, say when we're dividing rationals, aka fractions, well, we actually don't like dividing by fractions. We need to keep the first fraction, change it to multiplication because that's what we want to do, but we have to flip the second fraction. So it's called the KCF, the keep, change, and then of course F is for flip. So we're going to flip this one over. So the first thing I'm going to do, I'm just going to get ready. I'm not going to worry about anything else yet. So we're going to get this fraction ready. It says x plus 3 squared, x minus 3 at the bottom. I'm going to change it to multiplication, and I'm going to flip this one over. So it's x squared minus 9 over the x squared plus 3x. Okay, well, now that it's multiplication, well, I'm going to bring back what I did earlier, which is I'm going to factor. Well, actually, I'm going to make one big fraction instantly. I'm going to factor, and then I'm going to cancel things out. Anything from the top can cancel with anything from the bottom. So they said, make one big fraction. Okay. There we go. First thing I see is this. And it's already factored. I know that because it's in parentheses, but it does have a power of 2. Well, I'm going to do what I did earlier in that other problem where if it has a power of 2, I'm just going to write it twice. Remember, canceling is coming later on. And so I want to make sure that I see it as 2 parentheses. Now, the next one, they want me to factor this. Well, once again, it has 2 terms. Remember, this continues to be on the top. Well, when it has 2 terms, I'm supposed to write down 2 parentheses. When it has 2 terms, right, a difference of squares, I'm going to write 2 parentheses. It says x squared, so I already know to put 1x and 1x, because that's what gives me x squared, x times x. But in a difference of squares, I want to get a 9, and it has to be the same number. So that's 3 times 3. Well, there's my 3, there's my 3. And according to the word wall, one's a plus, one's a minus. So that takes care of that pink one for us. Well, now I'm going to look here. Now, when I look at this one, it doesn't have a power of 2. Well, then I'm going to ask about GCF. Well, this has a letter, this one doesn't. This has a number, this one has that invisible 1. So there's really nothing I could do with this one. Well, that means I'm going to write it down. But remember, I'm going to write it in parentheses because I want to remember the fact that it's all or nothing. So I checked it for GCF. There was no power of 2, so I couldn't do anything else. So I write it down, but in parentheses. Which brings me to the last one. When I look at this one right here, yeah, it has a power of 2. And it only has 2 terms like that one did. But notice, it does have an extra x. So for this one, it does have a GCF. The GCF is x itself. So when I write it down over here at the bottom, remember all of this goes at the bottom now. It has an x. There's the GCF. I write it down. But now all I'm going to do is I'm going to divide everybody by that x. So when I look at this one, here's my parentheses. There's a plus sign. I should have a plus sign. 2 minus 1 is 1. So I'm only left with 1x. The x's here go away, leaving me with a 3. So again, when we get this type of problem and there's multiplication, we make one big fraction, and then I take my time with each section and factor it. And remember, if it's already factored, well, this one said write it twice, so we wrote it twice. Because now it's time for me to cancel things out. And the rule is I can cancel anything from the top with anything from the bottom. So I see an x plus 3, I see an x plus 3, that one goes away. I understand there's another one, but you're only allowed to cancel one at a time. This one has an x minus 3, and this one has an x minus 3. So now the question is, well, can I cancel these two? The answer is no. You can only cancel top to bottom, not side to side. So they're kind of done. There's still an x, and once again, if you're thinking, well, I could cancel these x, you can't. That's why we put things in parentheses. It's all or nothing. You can't cancel little parts. So if that's it, if that's all we have left, well, then here's my answer. It's x plus 3. X plus 3 is what's left. X at the bottom. But of course, chances are it's really going to look like this on the test. There's the x that was left underneath. But this one, because they wrote it twice, then I'm just going to leave it here with a power of 2. And this is what it would most likely look like on the test. All right, now don't forget, you do have U-Dos to try out. You don't have to do the honors questions if you're not in the honors class, but you need to do all the U-Dos up to number 18. So let's get to work, let's practice and get ready for this final.